good morning, afternoon, everyone. So my name is Khan. I'm a principal engineer in for compute team, and also we have Lily is also come from my team. So today we will talk about the for app testing. So on this presentation, we will discuss approaches, testing framework, and then we will demo on how we can apply the approach and the framework in action. At the end of the talk, I also would like to hear your feedback on whether you already use the approach and whether is it helpful and what challenges you face. I see we have a few conversation on Zoom chat, and I see your challenge is also quite familiar to me. I would love to hear more feedback after that. Yeah. Okay. Next slide, please. Yeah. So before we discuss about how to test an app, so let's look at how a fork app can be built. So a fork app can have three components. Fork UIs. So this is where we define the UI for the users to interact with the app. And we have a fork backend. So this is where we define the backend logic. Now, normally it will be where we can implement the resolver for the UI invocation, for web trigger, sync events, product events, schedule triggers. I think recently we also have some thing called robo agent in Fork. So you also can define, like, for example, robo action also. External server. So just now someone also asked how about the testing on external server. So maybe we have the component on the top right here. So this one we often call is for remote compute in internet. I think it's only we also call that, I guess. And which also defines some backend logic that is run on app developer infrastructure, not Atlassian. So this is what we are not very recommended. Okay. But yes, there are some complicated app that require that, and we provide that one, I think, last year. Just to call out, not on app have on those three components. For example, robo agent app can just need to define the fork resolver for robo action. So they just need to have they might just have the fork app backend component here. Yeah, and some app can have no app resolver. Some app can have no external server. Yeah. And you can see for each component here, they can interact with, for example, fork UI can call the UI resolver. Can trigger UI resolver, which trigger the fork app backend code to run on the Atlassian infrastructure. And on the backend code, that one, the fork function also can call the external server or fork remote compute. We also can call Atlassian to update the 1P data. We also can call some API to update the fork app storage. And also there will be a case, for example, in terms of the product event. If a user, they update some data in 1P, 1P here, I mean Jira and Confluence, and then it will trigger some change on the product. And then if the app listen to those product events, there will be some webhook that trigger the fork app also. Yeah. So that is how the kind of like architecture or structure of the fork app, what component and how it's interact. Yeah, next I will share with you some common approach and also like testing framework that we can use for testing. Yeah. So so as you can see on this one, I didn't plan to cover external server, but I can talk a bit. I didn't put in the slide, but yeah. But then when we have there are different testing approach, and which each approach there are also different tools serving for that purpose. So for testing approach, we can test the fork UI for backend, and also I mean in terms of remote compute or remote server is also the same. We can test for app UI, for app backend, and remote server separately. We can use mock if it's needed, and then we can test each server, each component independently, right? Normally fork UI is going to be where we define the UI and the JavaScript, and they will need to get some data from, for example, fork backend, or maybe from directly from 1P, so we can mock the data. For app backend, normally for backend, we'll need to call to product API to get some data. That is where it depends. And also it might call the remote server. And then we also can mock the data to test the fork at backend separately also. And same at remote server. So the remote server actually is just a backend. So I think it's similar to one of the backend where we also can test the component independently. And now when we integrate all of the component together, so we can write some kind of end-to-end testing. In this way, we can validate with real data on Atlassian side, including like UI rendering, JavaScript, product data at Atlassian, data and for storage. And also to call now, if we want, we also can just test also the your remote server, because if it's your test server, you can expose some kind of like access, and then your test script also can trigger to your server to validate the data. Yeah. And later Lily will demo that one, then I think you will get some ideas. And we can talk a bit more on how to extend it for remote servers. Yeah. For testing tool, we also we would like to recommend to use some popular framework, including JS, React testing, Playwright library, Selenium or Playwright. We are using Selenium on our demo today, but actually we also see Playwright is a new one, and it's also very easier to use for automation tests. And we also internally we also have some tests that migrate to Playwright. I think and then Fox UI, this is the just UI tool, but it also can write together with your testing script where we can deploy. For example, we can deploy the app, we can install the app and uninstall the app. Yeah, so that is something that we also can use together with our testing script. And last but not least is Atlassian OAuth API. This one is actually quite powerful, and I think Tobias just asked a question about how we can setting up the data. So, and right now, actually it's quite interesting. I'm not sure whether we have. I can check whether we have some kind of sandbox, but as far as I know, we can use Atlassian OAuth API to set up the data, and then you can clean up. Maybe some app very complex where the setting up and clean up, reset the data is complex. But if let's say maybe later in the demo I can talk a bit more after that, how we can use for that purpose. I think that is about the approach and testing tool. So next, Lily will give you a demo to show how we can apply those approach and using the testing framework to test the fork. Yeah, thank you.
Thanks, Khan. So I'll be demoing quickly a forge app that we've built with some tests, just to show you all some examples of how you can set up these tests that Khan was talking about. So just going to swap out my screen sharing quickly so I can share some other windows. Let me just... Okay. We have a forge app here, which basically all it does is it checks who has commented on a Confluence page, and then it displays information about the name of the person who's commented and the last time they've commented on a page. So this is the app that we're testing against. And a quick overview of the architecture of this app. This will just help us understand how we want to divide up the test to test the app comprehensively. So in the front end, we just have the app component, which basically just lists the entry point to the front end of the app. So that will display everything that you see on the front end. And within that, we've created another component called commenters table, which is where we display the commenter information that you've seen on that page just then. That app component invokes a backend resolver called getCommenters, which gets information about the commenters from Confluence API. So it makes an extra call out to Confluence. And then it will manipulate that information and pass it back to the app so that we can render the commenters table, as you've seen on that page just then. So first we'll have a look at how we can test the front end, the Forge UI. So in this scenario, we want to mock everything that comes after the UI, so anything that the UI is dependent on, because we want to just make sure in these tests that the UI itself is behaving the way that we expect. So in this scenario, basically, we're only testing the app and the commenters table components, and we're going to mock everything else that it uses. So quick glance at the tests that we've written. First, we have a unit test, which basically just makes sure that given some sample input, the output is what we expect. So this is the sort of the lowest level test that we have, which basically just makes sure that the commenters table is rendering things correctly. And the way we do that is we just pass the input that we think we should be getting from the resolver in to the commenters table component. We can render that using a React library. And then that will eventually show up on a screen object, which we can check and make sure that the output that we expect is there. So in this case, we want to make sure that the user information and the time they last commented is displayed correctly. Another kind of test that you can set up for the front end is a snapshot test. Basically, this is pretty similar to a unit test, but it's a little larger scale because the first time that you run this test, basically it will take a snapshot of what the front end looks like. It will be sort of like a HTML file. I'll show you all what that looks like later. And in future runs of the test, it will compare the output of the front end to that snapshot. So basically just making sure that the front end that currently exists matches what you have expected in the past. So that's a second example. Finally, there's an integration test that you can also include for the front end. This is slightly more comprehensive because it also checks that the contract between the front end and the back end is correct by mocking the invoke function, which calls the resolver. So here, we basically pushed it like one step further than the unit tests, and we're saying, given that the invoke function behaves the way we want, this is the output that we want to be seeing. So that's also a kind of test that you can have for the front end, and it's very similar in format to the unit test that we just saw. So I'll run these tests in the code that we have to show you all what that looks like. Just to check, can we all see the code right now? I just want to make sure I'm sharing the window correctly.
Yep, can see it.
Okay, perfect. So yeah, quick overview of this testing structure as well. Is we have the test which tests the front end in the actual front end folder, just makes it easier to organize. And it also allows us to run like testing commands separately. So yeah, here we have tests specific to the commenters table. This is the integration test I was just talking about. We also have a test file for the app component, which has a unit test and then a snapshot test. And then the snapshot here has been generated just by running the test. And it basically will just check every part of the CSS to make sure that it's what we expect. So as you can see, it's a lot more detailed than the checks that the other tests are running. So this is what that snapshot looks like. And we just have this set up with Jest. So here these are tests that we just run locally. So we've set up a command that allows us to run all the tests in the front end. That will run those files. And you can see that, yeah, it'll log things out. These are just warnings about some of the IDs that we have, but you can see all the results from the test there in your terminal. So yeah, that's our front end test. Moving on to test the back end, so the resolver. So here we basically don't really care about what's happening in the front end. And now we're just testing that the back end, the resolver is behaving the way that we expect. And similar to what we did for the UI, we then just mock everything that the backend depends on. So in this case, it's the Confluence API. This is helpful because sometimes APIs can be a little difficult to handle in tests because you have to set up auth, you have to set up a whole bunch of things which maybe you can't do locally. So this is like a neat way to make sure that you're just testing that your backend component is working correctly. And you can just like assume in these test scenarios that the dependencies are working correctly. So here, the main test we have that will demonstrate is a unit test, similar to the front end. We're basically just passing in, here we're just mocking the API response and checking that the output is correct. So here we're just assuming that, let's say the Confluence API response is correct. Are we dealing with that correctly? So in this test, we've mocked that API response. We call the function in question, which is here it's the get comments, author ID and latest comment function. And then we check that the response is what we expect. And we can run that in a really similar way to how we did the front end. So I'll just demonstrate that quickly. We have this test here. As you can see, we've mocked the API functions, which live in a separate file. And we define what that mock response should be coming out of those APIs. And then we mock that as a response from the functions and then check that the response is correct. So here we can run the tests just as we did before. So we can do run test backend. And then once again, it'll give us a neat summary of these are the functions that have been tested. These are the tests underneath that, and then whether or not they've passed or not. Yeah, so that's the backend. Finally, moving on to end-to-end testing. This is as comprehensive of a test as you can do. It's testing that the app behaves as it should in a real-world context. And it's a little more involved, the setup for this, but it gives you a really good picture of whether your app is behaving the way you expect. So in this test, the way we've set it up is we have installed our app into a test site. So we can see that in this screenshot here. And we've put in some data, and in this case, that's the comments. So that's the things that our resolver will be interacting with. And we have set up our test to interact with that app on that page. So I'll go through the code first and then show the demonstration for this because the demonstration is a video in this scenario. So just quickly going through this end-to-end test. Here we're using Selenium WebDriver, but as Khan mentioned, you can also use Playwright for this. Those are just libraries that will allow you to mock up like the browser and interact with it. So it gives you the interface to do that. So here, the first thing we've defined is sort of a helper function to help us log in, because when you're interacting with an actual site, you do have to do all the auth, unlike in the unit tests. So here we're just manually logging in. What this will do is bring up the login link, click on, fill in all the information and then log in. I will just note as well that in this scenario, we've set our auth information in environment variables, or you can also set it in an M file. But here is where you maybe want to put some consideration into how you're storing your auth information securely. Because yeah, doing this end-to-end test, you will need that because you can't skip the login step. But yeah, just to note there. And in this scenario, I've used a personal test email that I've disabled two-factor auth for because that just makes the login process easier. So just some things to note there, things to consider. I saw some mention of how like pop-ups and the login can be a little annoying for testing. So you can get around that by yeah, maybe making a separate test account and like changing the settings just for that account. And then in the actual test itself, we initialize the driver itself, which will it's basically like the test browser, and then log in to the page and then go to the app page, which is the page where the app exists. And then using WebDriver, we can find the elements that we want to check have the correct values. In this case, I want to make sure that the commenter on the page in the table is the correct name. So I can pull that element out and then check the text there and make sure that that's all equal. So yeah, that's the setup for the end-to-end test. I'll do a quick demo of what this looks like. Basically, it's all automated. Oh, and also another thing is that you can simulate any user interaction you need with this library. So you can click things, you can scroll. There's a whole bunch of interactions you can do.
Yes, Glenn.
Oh, sorry, someone might not be muted, but yeah, you can do any interactions that you'd like with this driver, which is really helpful. So I'll I'll play this video of the demo. Basically, you'll see that when I run this test, it'll pull up a browser and all of these actions are automated. So it allows you to do manual testing without it being manual. It automates the whole process. So like I mentioned, this logs in to my account so that I can access the page where the app is on. And I've already given my account access to the site and access to the app and everything, so it will work smoothly. Here, it's just waiting for the page to load, and we can see that this is loading up a live page. So this is this is a real site. My app is on this site. And then it will wait to make sure everything is rendered and then check that all the elements have what I expect it to have, which it does. So that's a really handy form of testing. And it allows you to see pretty comprehensively how your app is behaving. And yes, as a summary of all of those tests, like I mentioned, end-to-end tests are a little more effort to create, but they are really helpful. They basically they are fully comprehensive, so you can rely on those end-to-end tests pretty well to check the state of your app. And then integration unit tests are just helpful for having a sort of lower granularity picture of how your app is behaving, so you can test specific components, and that helps you to debug things. So if something breaks, you know exactly where that has broken. So altogether, it helps build a pretty good testing picture. We would recommend running these tests maybe as part of CI/CD. This is helpful because then you can also combine these tests with deployments, when you merge app changes, you can check then the tests against those changes, which is really helpful. Or also even just running them regularly as a part of automated regression tests is really helpful, just so you can have a regular picture of how your app is doing. And yeah, these aren't all of the tests that you can write, but it's sort of just like an overview of the different types of tests you can have and like what we would recommend having for a Forge app. And then also, if these tests do help you find issues, just as a helpful toolkit, here are some things that you can use to debug your app. So firstly, tunneling is really helpful. It means that you can make live changes and see them live in your app. That's really helpful for just being able to find exactly where the issue is going on and seeing if fixes will actually fix the changes. We have a runtime debugger, which basically you can integrate with VS Code or whatever you write your code in, and that will allow you to like set breakpoints and step through your code and see where things are broken. We also have a front-end debugger, which sort of does similar thing in the front end. It works with Forge Tunnel, and yeah, that's good for just troubleshooting what's going wrong with your front end. And yeah, we have a previous DevDen talk that Khan also worked on where they talk a little bit more about debugging with Tunnel, which could be helpful. But yeah, those are all helpful tools to help you with debugging as a follow-on from your testing results. Yeah, that's it for the demo. I think we have a lot of time for Q&A now, so I'll pass off to Ian. Yeah.
Yep. Yep. Thanks for that, Vin. Yeah. Thanks. Yep. Clap, clap. Nice demo. We do have quite a number of questions, some of which were already answered in the chat, but some are left unanswered. Before we move on to the questions in the chat box, does anyone want to ask their questions live? Show, raise hand. No. Okay, then we'll go to the chat then. Let's see which ones aren't answered yet. So
maybe I
there's this.
can go through
Oh.
summary a bit, so I just answer some question or get some feedback. So I think the first thing that challenging on the how we can write the testing setup, right? Like for example, setup and tear down after the test. So some of you asked how we can easily do that. I honestly, I didn't look at it much. I know we are having Atlassian OO2. So in some example, for example, if we have a such macro, what we do is because maybe it's not impacting a lot. So we can create a new page. We can insert a macro by doing also some Selenium that we can insert a macro on a page automatically, or we can delete a page. But yes, there are some challenge, some case that like it take a lot of time to set up and reset. And if we can do some kind of like store in the state and revert it back, Atlassian can do automatically that would be great. I can follow up with like for example, Gija or Confluent team to see whether that is something possible. Yeah. The second thing is about the using in end-to-end test for you got a problem with logins. I think we also as an external developer, I also noticed that it's some challenging that we faced here several times. I think one of the let me see who just sharing us the library OTPOs. Maybe I think he shared that it is successful to be able to use. So maybe something you can try. Because again, with Selenium or Playwright, we also can simulate the key in the OTP as long as we can get the OTP. So there's a library there. What else? Let me see whether any question.
Yep, we do have a question from Marek.
Oh yeah.
About the use of jest mock, so to cheat tight coupling. So is there any technique you can recommend for test-friendly architecture?
Yeah, I see. That's a good question. I think in general, what we do is we try to put everything related with Confluent. So basically, we're doing at the architecture of the code architecture level. So in our case, what we do is that on of the for Confluent API, we go grab them in one class or one files where we don't do any business logic there. We just make a network con to Confluent by calling like I think as app or as user. Call request via Confluent, and then we pass API. We do some kind of login and return the JSON. We don't do any kind of like transformation or processing the response. All of that one will be separate by another class or yeah. So I'm not sure whether it's addressed your concern, but that is how we can try to separate the dependency, and then we just mock the Confluent API's response. Yeah.
Okay, thanks. Did that answer the question, Marek?
Partially, yes, but I think it would be great to see a part of code how you deal with this, because I would expect there are many pitfalls, because it's it's different way of coding than we used to do in server environment. It's just lambdas. So I just consider that you have code and warm lambdas. You can on this bootstrap of lambdas you can maybe prepare some configuration, and this configuration can use this dependency injection or port adapter or something like this. But I don't know if this is legal in Forge or not. I used to server architecture when everything is easy, because you just build your application with components, and just exactly like you do in Jira. Yeah, you just build everything in the Pico container or Spring or something like this, and then you just have this testing possibilities in separation. You just can separate your component and just have a port adapter architecture. So keep just all third-party dependencies in the adapters, and then you can easily test it. But I cannot see an example how to do it with Forge. You didn't provide any way of doing it, and we just need to figure out it from scratch. And it's very, very easy to make just mistake assumption.
So either your question is that, for example, one fork function or one lambda will call another fork function, and then how we can test such kind of thing. That's your question?
It's just overall architecture advice, because it's one simple lambda is just separation. We build applications. We don't build separate lambdas. Yeah, we build application which needs to work together.
Yeah, I try to understand your question. So my understand that right now, when we write a fork function, that fork function, what it can do is it will, besides that, any code you write, it's kind of like unit test. How to say it? So when we implement a fork lambda, we can call a Larsen API to update or get some data. We can call external server also to do something, update or get some data back. So that one we can, for example, we can mock them. But if we want to trigger another lambda and then we wait for the result, for example, not wait. I mean, if we trigger another lambda, then I think it's via a sync or web triggers. But in that case, I think if we expect some data again, we should put in one function and then we can mock that one to get. But if you want to see how they interact with each other, honestly, I don't think it's possible in how to say it, in end-to-end test. No, end-to-end test we can do to test, but what I mean is that when you call that, I think you only can simulate in your code, in your test. For example, you write the function, but when that one call is still a mocking. Yeah, so I don't see it's possible to do it locally.
Okay.
Okay. So there are a lot of related questions around a test Atlassian infrastructure mock, or if there are some ready-to-use mocks for the Forge packages. I believe that was. Did you touch on that one a while ago, Khan?
Either the latest question about the element changing ID. Sorry.
No, around Atlassian infrastructure mocks or ready-to-use mocks for Forge packages. Do we have any available packages?
Either
or
Marek
like,
question, either Marek question at 5626. Do you want to share the screen? Maybe it's easier, Ian. Oh, but you cannot share the chat. Sorry.
Yeah.
Okay.
Yeah.
I think so what time of the questions?
What if someone grabs some questions out of chat, puts them on like
Yeah.
a VS Code thing and just puts it up on the Q&A screen, so you like pick some ahead of time and might be easier.
Yeah, I'm gonna put it in the. Yeah, we have an internal tracker in here, but I can just post in this Q&A chat bot if I get it to work. That's
Yeah.
Okay. I can send you the slide link if you need.
yeah. So I'm gonna mention
Yeah, but
you, Khan.
actually, Ian, maybe like if if you can add them like even to like a Confluence page just to say something so that it's
Okay.
visible on YouTube as well. Otherwise,
Okay.
it will not be visible in the recording if you use the Q&A of Zoom.
Yep. But the goal is for Khan to see this one. So Khan, I tag you.
Yeah. Yeah, got it. I think we don't have that one yet. So Andre, you got kind of mocking you are looking at? Like what kind, maybe you can share more your need so that we can see how understand more your need on this.
Andre, are you still so
Okay.
is he still in the call? Yep,
yeah.
there you go.
I'm interested in a set of mocks ready to use to mock all the Forge infrastructure in our model tests, internal testing, because, for example, with key value storage, we need to test how do we query some data from it, and we needed to write our own in-memory implementation of this search and test our code with our mocks. It's kind of unproductive and could cause many issues because we might implement something different. We might don't test something completely, etc., etc. So it would be awesome to have some built-in mocks for such libraries.
That's a good question. I don't think we have anything immediately right now. But it just make me a question like right now, if let's say if we just write a web page with backend and Redis, how you plan to test your backend code with the Redis? But do you run the northern Redis on memory or you still use mock?
Yeah, we expect to put everything in the memory, mock it as much as possible because we want our test run as quickly as possible without any network, at least
Yeah.
hopefully.
Yeah, I think the way you are mocking like memory and use some library to simulate, because you know that key store, you think maybe a bit like you guess, because it's a bit hard, not hard, but it's not very good approach that you want to need to know under that, like Fog will use Redis or something similar, and you can use some library to do that. So I think that one is my potential is still working, but maybe someday, I don't know, for example, there are some special command that is not work. But again, what I recommend is that based on the documentation of the Fog storage, for example, the key value store, I would suggest just mock it easier, and you might need to mock one by one command in the order. I know it's a bit. I think again mock is a bit tricky on this one. So yeah, we depend on the test. For example, how many read and how many write, and then you just write to get like the order of that, like the first and the second. Yeah.
Technically, we came to this solution, and yeah, we mock the libraries ad hoc. And one more question. Sometimes it's very hard to mock some Jira API requests because it requires us to make the similar request, copy payloads, try to break everything, find some invalid responses, etc., and mock this everything just to test some logic. Do you provide some example payloads somewhere accessible with NPM, for example? Because yeah, it's kind of hard to mock all the Jira API requests.
Right. So you want to see the schema, right? And then you want to understand the schema, and you want to have some place where you can get that schema and generate the mock for that.
Almost. Is there any way to do something like Ruby's approach with cassettes, when you could just run tests with your personal access token and then store all the payloads inside your data set and just reuse these payloads later?
Got it. Yeah. I think that's a good idea. I think we used to have also some talk about that, like how we can test the Fog UI, because the Fog UI might need make a lot of API call and on a lot of interaction. Even like want to test for a lot of things, like even when people click some button, that one will trigger the API via Fog bridge to get. So, but right now we don't have it. Yeah.
Yes.
I see one question related with yours, next to yours, that about talking about the KBS and like is there any mocking or any kind of like library so that we can simulate it locally? I think that's a good question. Maybe I could check with the team who always want to see whether we can have a such kind of thing to speed up the testing, also make it easy to when we run the test. Yeah.
Okay. And the next question, Khan, is from Felix Andre. Felix, do you want to ask your question live for Khan?
I just want to know if we can use Cypress instead of Selenium. It's work for Atlassian, Jira, and everything.
Oh, I think so far I didn't. I think now it seems that we are moving to Playwright, so that's what I can see. I'm not an expert on Cypress to answer whether it should be used or work well, but I can see that internally we are using Selenium, and we are trying to migrate as much as possible to Selenium. So that is something I have. Yeah, I'm aware.
Okay. Oh, this one is a follow-up question from Sean. So don't you have mocks internally to test these things? So is that a question for you, Lily and Khan? Yeah.
Yeah, that's either this one is a follow-up question on the key value, right? We just discussed, right? About the Redis and the key value store. So yeah, that's the good question. So I think again, I let me chat with the team who own the fork storage and see how we can publish whether it's possible to publish some kind of like library for every part to use that one. Yeah.
Okay. Thank you. I think we've answered most, if not all, of the questions in the chat. If we left something out, feel free to use the raise hand button, and then we'll try to answer your question live.
Can I just ask a question?
Go for it.
Like that?
Yep. Hello.
Yeah.
Yeah.
Hello again, me. Maybe I will rephrase my previous question because I said about this test architecture. So let me just rephrase it. What I wanted to do, I wanted to test my app, my plugin, just without infrastructure. So let's say without touching any Jira features, yeah, just to isolate it, yeah. And as I can see, the only technique you shown was to use this just mock, which is kind of not the best technique for the testable architecture. And I just wanted to ask you, is there any other recommendation how we can test our whole plugin without touching this Forge infrastructure? Yeah? How we can, for example, replace it? Because I mentioned port adapter, which is quite stable architecture for this kind of things. Yes, like we have adapters for example, database, for Redis, for REST API. We can create that. But do you have your recommendation how we can test our plugin with isolation of Forge architecture? Yeah.
Yeah, that's a good question. Let me have a think about that.
Because dealing with this infrastructure is sometimes a recipe for flaky testing. It's a recipe for infrastructure problem. It's a recipe for problems you can avoid having isolation testing. Yeah.
Right. I think right now the model, and you can see the way we write the fork graph, you will write a resolver and you will receive some kind of like, you will expect to receive some kind of a schema input. And actually it's not triggered by your front end. So basically just now you see the three components like fork UI and fork resolver. Fork UI is trying to call fork backend, but actually behind it, there will be something in the middle that is managed by a fork platform, and fork platform will do some kind of like, how to say, when we trigger the fork backend, we also send some data, and that data is not available on fork front end. For example, when the fork front end call, you pass some payload, right? But actually, there's a lot of context for them about the current page, what is the for them, whether the macro, who is the current user, what is the installation ID. That one is provided by fork platform. So if you ask about whether you can run to separate your app without the fork platform, I don't see it at the moment. It's not possible right now because you cannot trigger your app. The backend code, for example, by yourself. You still need to get some input. So unless you mock that one and try to simulate the calling, for example, when we write the fork function, we go implement it as the resolver, require payload and context. So you still need to trigger that one, and with some kind of like data, sample data that when you do fork tunnel, for example, then you can print out to see what the fork platform will send to the fork backend. then you can use that one to try to test your programs. Yeah. Yeah. So at the moment, yes, I think we don't have an easy solution, or I'm not aware that it's possible to test. Yes, if we do the unit test, then you don't need to depend on the Atlassian architecture or API. But if you want to test between the, for example, Fog UI and Fog Backend, then you need to run on Atlassian, because, and just now explained, there's a Fog platform stand in the middle that forward the con from Fog UI to Fog Backend. So if you don't run Atlassian, then you don't receive that one. So then you need to do the mock-ins. Yeah, we need to do the mock-ins.
Okay, thank you.
Okay, we have a question from Sasha. Oh, sorry. Marek, do you have a follow-up question before you move on to the next one?
Oh, thank you very much.
Oh, okay, thanks. So did I pronounce it correctly? Sasha, around
Yes.
KVS? Yep. Can you?
No, it's not about KVS in general. It's a general question if there's a good way to run your integration tests without having to mock the services, because especially when we get to more complicated services like Forge SQL, we actually want to test how the database behaves. And since it's now behind an API and behind a different layer, not directly an SQL database, I'm not sure how to best can this be run as an integration test, where actually the tests run in Forge infrastructure.
Yeah, that's I think that's a good question, and let me forward your question to the storage team. Yeah, so right now we don't have a subscribe library or able to test this. Using something how to say, so that we can run it on locally. Yeah. Yeah.
I haven't used any as well, so yeah, maybe that's something we can ask the engineering teams about. Yeah, last question is gonna be from Tobias. This is about CrowdPrim. Can you ask the question live, Tobias? I'm not sure if we have an answer here, but let's see.
I answered that. So I answered that in the chat. So it's about
okay.
like my understanding, Tobias, is about as part of the development environments to have access to a crowd premium site.
Okay.
And the answer to that is I've sent a message internally already. So
Okay,
I've noted
thanks.
it. I sent a message.
Perfect. Thank you.
Okay. Oh, okay. This is the latest one from Roman. Can you ask a question live? I think it's meant for. Is it meant for Lily? Or I can read it for you. So, but feel free to. Okay, I'll just read it. So, where front-end, back-end, end-to-end tests described in the project to be run using npm test?
Yeah, I think I can show that quickly. We've set that up in our. So we've set that up in two places. In our jest config, we've just split up our tests into 3 different projects, which basically means we can assign a name to files matching a certain regex string. And then, yeah, in package.json, we map the commands, which you can run with npm, to the jest command, which just selects the project corresponding to the files that we want to run. Yeah, that's the setup there.
Thank you. Did that answer the question, Roman? Okay, yes, so thank you. So I think that's a yes. That's the last question we have for today. We still have 7 minutes, but yeah, we do have a lot of questions coming in. So thank you. We love the engagement. And it seems like testing is a really hot topic. And perhaps we can do more about the same topic in the future. With that, if there are no other questions, I'd like to thank our presenters for today for spending time with us, sharing their knowledge, and for answering all the tough questions. So thank you. The community, the developer community appreciates it, definitely. Okay. And that's pretty much it. So I hope you've learned something of value today, and I hope to see you on the next Forge Dev then. With that, thanks everyone, and have a nice day.
Thank you. Have a nice
Yep, thank
day.
you.
Thank you.
Thanks. Have a nice day.